Hi there, welcome to APES Chapter 21 Lecture Video Part 2. This is the chapter on new renewables we just finished talking about in Lecture Video Part 1. We were talking about solar energy. Now we're talking about wind energy in this lecture. All right, so let's talk. Wind. Well, wind moves, so therefore wind has a lot of kinetic energy. That's the energy of motion. If we can get that wind to spin a turbine, then we can generate electricity in the generator. So just like before, how is electricity generated? You need to know this. What happens? Well, in this case, wind will spin the propeller of a turbine that will move magnets inside of a generator around copper wire, and that will cause electrons to move and lead to a current. So that's how electricity is formed using wind power. What is wind? Well, the movement of a mass of air. Where does wind move? Wind moves from high to low pressure. It always moves from where there's a lot to where there's less. High towards low pressure. If you remember in one of our earlier chapters, areas of high pressure, okay, areas of high pressure will have generally the clouds will leave the area of high pressure. So this picture is a little bit off. Let me show you why. It's showing right now that the clouds are here. Okay, these clouds are going to leave, and wind is going to push them to an area of low pressure. They're going to push them to this area here. Okay, that's what's happening. So areas of cold areas have higher pressure. Why? Cold air sinks. Since cold air sinks, it pushes down and creates more pressure. All right. So areas of high pressure, this picture is deceiving in that these clouds are going to leave. Why? Area here is now high. This area is low. They're going to be pushed over here towards this area. All right. So what's happening? What's happening? We're talking about this. Air moves from where there's a lot to a little. Why is air here have low pressure? Well, when air is getting heated, it rises and it's not pressing back down. That's low pressure. So things move from where there's high towards a low pressure. What causes high and low pressure? Well, uneven heating of the land and water masses will create this change. So how does air move? Well, it's going to move from high to low. It rises and then it creates what's called a convection current. It rises, floats back over, and comes back again. It really will be moving like this. So it'll move towards here. It'll get heated up. It'll rise. It'll float over. It'll cool down. It'll get heavy. It'll sink. And it'll continue on. So this is the movement of air. This is a convection movement when it moves around in the circular pattern. Make sure you understand this, though. In nature, you should know that these clouds will end up in an area of low pressure. So where do you generally have rain? And these arrows are not showing rain. These arrows are showing air pressing down, creating pressure. These arrows are showing air going up, creating less pressure. So this is not precipitation. These arrows are showing air pressing down, creating that high pressure. Okay, so these clouds will leave the area of high pressure and go to the area of low pressure. What is a wind turbine? Well, here's a wind turbine. You got a blade, three big propellers, and they start spinning. And when they spin, inside of them, there's a gearbox. Why is there a gearbox? Because it can actually increase the speeds. It's kind of like the gears on your bicycle when you want to go uphill versus, say, going downhill. You can change the gears. So they can change the gears of the gearbox. These are on average, about 80 meters or 260 feet tall. Right? So this box here is called a nacelle. Inside the nacelle, you have a generator. What's inside of that generator? Magnets around wire. That's what you got inside there. And they're going to move around that wire, creating the current. Um, Engineers have designed these things. They've designed them to yaw, or what does that mean? To rotate back and forth. Why? Because wind changes direction, so they can move in different directions. What people don't know is that small changes in wind speed can create huge output differences of electricity production. So let me give you an example. Doubling of wind speed, so wind speeds double, increases your power output 8 times. So it is not just twice as much more power. You have 8 times the power if you double the wind speed. All right, so it shows you that it's a cube function. 2 times 2 times 2 is 4. 2 times 2 is 4 times 2 is 8. So this is the equation is a cube function, which is why doubling wind velocity doesn't just double power. It cubes the power, 2 to the third power. It makes it 8 times more power output. They're generally erected in larger groups. If you ever driven up in Northern California areas or through Arizona or to Palm Springs here in Southern California, you'll see wind farms out in the middle of, it looks like we're out in the middle of nowhere, like between the mountains and these flat areas between mountainous areas where they're having a lot of wind flow. Well, wind power is growing. All right, it's doubling about every 3 years. It used to be years ago. It used to be the fastest growing form of renewable energy, but solar photovoltaic solar cells have overcome that by far. Which countries use it the most or produce the most? China, the U.S., and Germany. These are the big producers. People, you need to understand that wind turbines have been around a long, long time. They were used like in windmills. They were used in farming to pump water to do different things like that. So windmills, wind harnessing and wind power generation has been around for a long time. It's not just present day where we're using it to produce electricity. Um, Denmark, for example, is one of the world leaders on wind. About 40% of the country's electrical needs come from wind power. That's pretty awesome if you really think about it. They're just much, much smaller than we are. China, the US, and Germany, of course, we lead the world. We lead the world, but Denmark is pretty impressive. Per person, they're one of the highest. And specifically, this 40% electricity needs comes from wind power is awesome. The US, most of our energy in the US generated in Texas. Most people think of Texas as the oil state. Well, those people, they're all about money and energy. And if you can generate energy using wind, why not do it? If the costs are effective, they will do it. Iowa and South Dakota are other places that are the number two and number three places in our states that are producing it. They're producing more than 25% of their electricity needs from it. So it shows you the places in the U.S. that are using it are also fossil fuel places. So they're energy companies that move into these places. So they look for the ways of making money. Since the government subsidizes fossil fuels so much, you generally notice energy companies involved more in fossil fuel extraction. Offshore sites, here's what they look like. There's more potential costs and potential, not necessarily danger, but malfunction. You're dealing with salt water, which causes corrosion and things of that sort. When they do erect them, they're generally in shallower water, and they anchor them in the sediment below. Why are offshore wind farms better in some cases? Well, wind is faster, and I just told you if wind is faster, you're producing a lot more energy, and that's what's happening there. Also, wind over water has less turbulence, so that means it's more steady over water anyway. So it's actually a better place to put it. Here on land, there's more turbulence the lower the turbine is. So the wind isn't as steady. So generally on land, you have to make them 80 meters higher, 260 feet tall. The taller they are, the less turbulence they're going to have. So benefits of wind power, very similar to solar in that they have no emissions. And here's a key factor. I don't know if I mentioned it, but you need to understand this with solar also. Equipment production is where any emissions are made in solar and in wind power. So when you talk about emissions, every now and then you'll see a statistic that'll say there are emissions in wind power, there are emissions in solar power. Those emissions are calculations involving the production of the equipment and installing the equipment. So yes, there is an energy expenditure in installing and building and manufacturing and mining, for example, depending on what it is you're looking for to put in that equipment. So yes, the production has an ecological footprint. Just producing solar power or wind turbines or solar plates, for example, it has a little bit of an ecological impact. This gives you an example of a 1 megawatt wind turbine. So if we were to shift towards wind, and it is believed that the U.S. by around 2050 could achieve about a third of our energy needs from wind, just wind, that is. But that is the belief. If we actually put more money into it and allowed more subsidies from the government and tax credits to go into it, it would develop that way. A 1 megawatt wind turbine, here's what it does. All right, comparing it to fossil fuels. In energy production, if you're comparing it to a fossil fuel that's producing the same amount of energy, 1,500 tons of CO2 will not be released. Tons, 1 ton is 2,000 pounds. So let's give it to you in pounds. 3 million pounds of carbon dioxide. That's crazy if you really think about that. That's one wind turbine. Sulfur dioxide, this is what creates acid rain, one of the things that causes acid rain. 6.5 tons. So multiply that by 2,000. That's how many pounds it is. 3.2 tons of nitrogen oxide. These also lead to acid rain and lead to smog and other things. 3.2 tons less of that. Mercury, remember, mercury is released during the combustion and excavation of fossil fuels. 60 pounds of mercury. Doesn't seem like a lot. We're 60 pounds, but you got to understand mercury is bad for us when we're dealing with parts per million. Small amounts of mercury make us ill. We're not talking 60 pounds is a lot of mercury. Okay, so it would make us very ill. Another benefit of a wind turbine. So these are prevention methods. A one megawatt turbine would prevent this if you're comparing it to fossil fuel combustion. The EROI, the energy return on your investment, is 20 to 1. What does that mean? 20 times more energy is returned than is so they get 20 times more energy than they consume. Okay, they produce that much. There's no fuel once you build a wind turbine. There's no fuel cost, just like solar. And also, here's a huge benefit. Valhalla right now is a solar farm with our parking lot. You can have wind farms. You're not going to see any wind farms locally like where we live or here by our school, because the zoning laws which allow you to build certain things will never allow you to build that kind of structure in these areas. We'll talk about that in a second. Farmers and ranchers on their land can build them. Um, that that one wind turbine can supply energy to a large community of people that live out in the rural areas. If they want, they can use it to make money. A single wind turbine can bring in royalties of $2,000 to $4,500 a year for one of them. The nice thing about this, the reason I'm saying farmers and ranchers, is these are 80 meters tall, so they're not affecting their farming. They're not affecting the sun exposure. They're not affecting their cattle on their ranches. So they can erect these in areas and they can still have farming taking place around it. So they can optimize income in multiple ways. Problem with wind is it's not always blowing. It's intermittent, just like solar is intermittent, and the sun drives wind because of the changing pressure. So they're definitely directly linked to each other. So it's an intermittent resource. The geography of where it happens to take, it only happens in certain places. In the U.S., the best places are mountainous and the Great Plains. If you look here, wind power capacity, Texas leads the way. We have a decent amount here in California, and you do see them. Here's the Great Plains region where you have the more wind. You have a lot of areas here where you can take advantage of it. Wind power, if you notice, there's more wind power in coastal areas. All right, so talking about more like offshore sites, but a lot of offshore sites they don't fly, and I'll tell you why in a second. And look, wind generation, the Great Plains, so mountainous areas here. Okay, so some mountainous areas and Great Plains and coastal areas here. Now, the reason you're not going to see wind turbines going up everywhere is because of this concept called NIMBY, or not in my backyard. What happens is people who live in an area, they spent money on their home, they pay property taxes there. They want it to look nice. They don't want this giant wind turbine in their, every time they look out their window, they don't want to have to see that. So this is called NIMBY syndrome, or not in my backyard. You're going to hear this term in your lifetime, and now you're going to know what it means. It relates to the concept where people don't want something near where they live. They don't want to see it. But do they need it? Yeah. Or do they want it? Yeah. This is currently happening near where I live. Where I live, there is plans to build, and this is interesting, there's plans to build a mega church, 1,000-person plus church near where I live. There's a plot of land where they want to build this mega church. And the people in the area are not happy about it. These people in the area, I bet a lot of them will even go to that church. They will probably even attend the church. They still don't want it in our neighborhood. Why? They think it's going to develop an area of land that they didn't want developed. They want to keep it undeveloped. They think it's going to bring traffic. It's going to bring congestion. It's going to bring a lot of people in that area, in the area where people weren't normally there. So they don't want all that congestion, all those automobiles, all that traffic, all that, whatever comes with a large mega church. So the not in my backyard syndrome is a problem that we have. One of the problems with making offshore offshore wind farms is people who have homes don't want to see them when they're looking out at their view. If you've ever been in Los Angeles area or Huntington Beach, for example, you'll see oil rigs off the coastline. You own a $2 or $3 million home, and you're looking out your window, and you do not want to see an oil rig. So generally, wealthier communities, they have a lot of power. They don't want these things in their backyard. For example, we have you would never want a factory that's burning coal in in our neighborhood producing electricity. People would be ticked about that. They would not be happy. So it's a problem that a lot of people have. It's the not in my backyard syndrome, or NIMBY syndrome. One of the major problems of these wind turbines is ecologically. Birds and bats, things that fly, they do not do well with wind turbines. They fly into the rotors, the rotating blades, and they get killed commonly. Large raptors, golden eagles are large open country raptors. They're flying through these areas. And the problem is these open country areas is where you're going to have these wind patterns. So a way to prevent it is to not put turbines in areas where there's a migratory flyway for birds. But that's a hard thing to do. So this is one of the big problems. Some of the solar, some of the solar power or solar generation where they concentrate it, that also can kill birds. I don't know if I mentioned that to you. Those concentrated power towers where you have all those rays aiming at the central tower. Apparently, if birds fly by, they say they become a poof of smoke. So that can also kill birds too, but not as commonly. You don't have as many of those as you have wind turbines. So wind turbines are a bigger problem for things that fly. All right, we'll stop right there.